Welcome to our YouTube channel. In this video, you will learn how to develop microservices using Spring Boot application. Here are the prerequisites you should have before starting this tutorial. Basic understanding of Java programming language. Understanding the concept of RESTful architecture and how to design and consume RESTful APIs. You should have basic understanding of Spring Boot, including concepts such as dependency injection, annotation, and RESTful web services. It's important to have a basic understanding of microservices architecture, including its principles. You should have some familiarity with databases, particularly relational databases like MySQL and PostgreSQL and MongoDB. It would be advantageous to have some understanding of message queue, especially RabbitMQ or Kafka, and we will use them for our asynchronous communication. Knowledge of HTTP protocols and JSON data format will be good to develop and consume RESTful APIs. And finally, you should ensure you have some development environment set up with Java JDK kit installed along with suitable IDEs like IntelliJ, Eclipse or Visual Studio Code. If you do not know any of these things, don't worry, I have created a separate video for this and I have mentioned this in the comment section. So please stay tuned with that before proceeding for this tutorial. We will build flight booking system focusing on microservices pattern and using Spring Boot and the latest Spring Cloud technologies. Throughout the tutorial, we will explore the following topics. Service discovery. We will discuss how microservices can discover and communicate with each other dynamically, allowing for flexible and scalable architectures. Microservice communication. We will cover different communication patterns and protocol used between microservices, enabling them to interact and exchange data effectively. Centralized configuration with GitHub. We will explore the use of GitHub as a centralized repository for managing configuration on setting across multiple microservices. Distributed tracing. We will delve into the concept of distributed tracing, which helps trace and monitor requests across various microservices using Zipkin and Micrometer, a popular distributed tracing system. Event-driven architecture using Kafka. We will learn about event-driven architecture and how it enables loose coupling and scalability among microservices. Next, we will learn about circuit breaker using Resilience 4J. We will discuss the importance of implementing circuit breakers in microservices to handle and prevent cascading failures utilizing the Resilience 4J library. Then we will discuss on rate limiter using Resilience 4J and Redis. We will explore how to implement rate limiting to control and manage the rate of incoming requests using Resilience 4J in combination with Redis, a high performance in-memory data store. Finally, we will discuss about secure microservices using Keycloak. We will focus on securing our microservices by integrating Keycloak, an open source identity and access management solution to handle authentication and authorization. If you are not familiar with these terms, don't worry as we will explain them in detail. We will cover several features in Java latest innovations from Java 8 to Java 17. We will implement lambda expression. It introduces a new syntax for writing anonymous methods, making it easier to express instances of single method interfaces. We will also cover functional interfaces and new date and time APIs. Then we will see the streams. It introduces the stream API for functional style operation on streams of elements. Then we will see the default methods, which allow interfaces to have method implementation in addition to abstract methods. Seal classes. Seal classes and interfaces were made final by default. Local variable type interference variable. It allows the type of local variables to be interfered by the compiler. Text blocks. It introduces a new syntax for multiple strings. Pattern matching for switch, which improves the switch statement by introducing pattern matching, and many more features we will be covering. Before diving into the implementation of our microservices, let's take a moment to understand what Spring Cloud is. In the Spring IO website, inside the project folder, there are several projects. So Spring Cloud is also one of the major projects provided by Spring community. So if you see here, Spring Cloud provides several common patterns in distributed system like configuration management, service discovery, circuit breakers, and many more. We will discuss in detail about all these Spring Cloud design patterns. As a Spring Boot developers, we are always thrilled to explore the latest feature from Spring Boot community. Spring Boot has released the final version of 3.0 on November 22nd, 2022. Spring Boot 3.0 is built upon the Spring Framework 6, which brings several noteworthy changes that we need to consider during application development. We will use below features of Spring Boot 3.0. Spring Framework 6 is the minimum requirement for this Spring Boot application 3.0. Java 17 is the baseline version. We can use Java 17 or higher versions. Jakarta EE9 is the minimum version. We can use even higher. And Micrometer with implementing observability and problem details. HTTP exchange to exchange different microservices communication, Spring Native. In this tutorial, we will delve into this feature and understand them better. Before we begin, let me provide a brief overview of each feature. Spring Boot 3.0 now supports Java 17 as a baseline, although it previously supported Java 17 as long-term support version. Additionally, there are changes related to Jakarta EE. After the upgrade, Spring Boot 3.0 only supports Jakarta EE utilizing Servlet 5.0 and JPA 3.0 specifications. Moving on, observability is another important feature. By utilizing specific APIs or classes, you can publish matrices from your application. These matrices can easily be tracked and mapped in your cloud infrastructure tools like Zipkin and displayed on monitoring boards like Prometheus and Grafana. For handling HTTP specific errors, Spring Boot 3.0 introduces the problem detail class. This class allows you to map HTTP status specific errors in your project effortlessly. It simplifies the process of handling and presenting errors in a standardized way. When it comes to dependency upgrades, Spring Framework 6 and Spring Boot 3.0 have certain minimum version requirements. Ensure that you use Kotlin 1.7 or higher, Lombok 1.18 or higher if using JDK 17 and Gradle 7.3 or higher. Remember to keep these version requirements in mind when working with Spring Boot 3.0. Lastly, we will cover HTTP Exchange feature. It provides native support for declarative HTTP client interfaces using annotations such as HTTP method and @exchange. This annotation allows you to define declarative REST clients with ease, similar to how Feign enable consuming the APIs. Let's start with what are microservices. Microservices is an architectural style in software development where a complex application is built as a collection of small independent services that can be developed, deployed, and scaled independently. Each service focuses on a specific business capability and communicate others through well-defined APIs. In case of monolithic architecture, the entire application is single and tightly bounded, while in case of microservices, all the services are working independently. There are several benefits once you go for choosing the microservices. The first one is scalability. Microservices allow you to scale your individual services independently, which means you can allocate resources when they are needed most. This results in better resource utilization and improve the performance. The next one is agility. The modular nature of microservices facilitate rapid development and deployment. Teams can work on different services concurrently, leading to faster time to the market. Third one is technology heterogeneity. Microservices let you choose the best technology stack for each service. This means you can leverage the right tool for the job rather than being limited to a single technology stack. Independent development. Teams can work on different microservices without interfering with each other. This will help you to reduce the development bottlenecks and the conflicts. Fault isolation. If one microservice fails, it does not necessarily bring down the entire system. This isolation ensures that the failure of one service does not have a domino effects on others. Now let's discuss some of the challenges with microservices. Along with benefits, definitely there can be some challenges in the microservices. The first one is distributed system complexity. Then we can see the service communication, monitoring and debugging, data management, and testing challenges. There are two types of communication between services, synchronous and asynchronous communication. Now let's learn something more about the synchronous communication. As we have told, in synchronous communication, service A sends a request to the service B and it waits for the response before continuing its execution. It's like making a phone call where the caller waits for the receiver to answer the call and have a conversation before hanging up. Asynchronous communication refers to a mode of data exchange or interaction where the participants do not need to operate in real time or simultaneously available for the exchange of information. In asynchronous communication, the sender and receiver are not required to be actively engaged at the same time, and there is often a delay between when a message is sent and when it received or be processed. So when to use synchronous and when we should use the asynchronous communication. Unlike synchronous communication where participant interacts in the real time, means simultaneously, asynchronous communication allows for delays between the message transmission and reception. Participants can communicate at their convenience and messages are stored until they are retrieved. Email, voicemail, text messaging, discussion forums, and asynchronous collaboration tools like shared document editing platforms, for example, Google Documents, are some of the common examples of asynchronous communication. This is the architecture of our application. Now let's explore the various services we will be developing in this tutorial. The first service we will build is the flight service, which enables us to create and view flights within our application. It serves as a flight catalog, providing information about all available flights. It uses MySQL relational database to store the flight details. We will use global exception handling for controllers. It allows you to centralize the exception handling logic and provide a consistent response for various types of exceptions. We will also implement automation testing with JUnit 5. We will cover automation at controller layer, service layer and the persistent layer. And we will also see the integration using test container. Additionally, we will develop a flight search service that utilizes MongoDB to search for flights based on specific criteria such as number of passengers, origin, destination, and travel date. This service allows users to search for flights to their desired destination on a specific date. Furthermore, we will create a booking service responsible for handling the creation of bookings for users. we will store these details in MySQL database. The booking service will interact with the flight service to check the seat availability and reserve the seats on flight. The communication will be synchronous. Subsequently, the booking service will communicate synchronously with payment service to process the payments. After a successful booking, the notification service will be triggered to send the email notifications. We will implement the notification service using an asynchronous communication approach, employing an event-driven architecture with Kafka. We will implement Eureka Server to enable service registration and service discovery among microservices. Each microservice registers itself with the Eureka server during its startup, providing its network location, for example, host and port details. The Eureka server maintains a registry of all registered services and their locations. For synchronous communication between microservices, we can implement it using various approaches such as HTTP Exchange, FAN client, and Web client. To enable the microservices architecture, we will utilize additional surrounding services. An API gateway will serve as a centralized entry point, allowing user requests to be directed to different services without exposing individual hostname or IP addresses. Security measures will be implemented using an authorization server called KeyCloak. We will explore the implementation of circuit breakers in both the API gateway and the booking service. Additionally, we will delve into the mechanism of time limiter, retry, and rate limiting, utilizing Redis for storage and the Resilience 4J library for implementation. Furthermore, we will incorporate other services to enhance our application's functionality. This includes a configuration server, GitHub for centralized configuration management, Zipkin for distributed tracing, and Elasticsearch, Logstash, and Kibana for centralized logging. Prometheus is a monitoring and alerting tool widely used in microservices architectures. It collects metrics from various services and provides insight into their performance, resource utilization, and health. Grafana, on the other hand, is a data visualization tool that works seamlessly with Prometheus, allowing us to create interactive and customizable dashboards to monitor our microservices metrics effectively. To facilitate installation and deployment of our microservices, we will leverage Docker. Docker enables us to package our applications and their dependencies into lightweight containers. This containerization approach ensures consistency across different environments, simplifying deployment and enhances scalability and portability. We will also use Docker to install and configure Redis, Kafka, and KeyCloak. For the cloud setup, we will utilize AWS, Amazon Web Services, a leading cloud computing platform. AWS offers a wide range of services and infrastructure options that enable us to build, deploy, and manage our microservices in a scalable and cost-effective manner. Throughout the tutorial, we will delve into the logical architecture of each service, which includes the controller layer for handling HTTP requests, the service layer for executing business logic, and the repository layer for database interactions. We will be using MySQL and MongoDB databases for our application, and the message queue communication for specific services using Apache Kafka. Now let's start building the flight service. To build a Spring Boot project, let's go to this website starts.spring.io. This is a Spring initializer, and here we will choose some options. So first we will choose the project option. So the project I am choosing Maven. You can use Gradle if you wish to, and the language I am using is the Java. Spring Boot version we are working for this tutorial is 3.0.8. As you can see here, there are several snapshot versions. Ideally, it's a best practice not to choose any snapshot version but some stable versions like 3.1.0, 2.7.13 and 3.0.8. But in this project, we will be focusing on 3.0.8. Now let's define some project metadata. So for this, we will be using the group as com.techworld and the artifact as flight service, the name also same flight service, and provide some description like develop flight service as microservice in the Spring Boot application, and then the package name. So this package name is the group along with the artifact, so com.techworld.flightservice. And the next option is for packaging. So let's do the packaging as jar. And for Java version, as we are using the 3. Version of a Spring Boot, so minimum requirement is Java 17. Now let's add some dependencies. So first dependency we will add is the web dependency. So this web dependency is used to include RESTful application using Spring MVC, and it also uses Apache Tomcat as default embedded container. So for this entire application, we will be using the Apache Tomcat. Click on the enter button and the Spring Web dependency is added. Now let's add one more dependency called as Lombok. So this Lombok library helps to reduce the boilerplate code. So let's click on add. For time being, let's only add this two dependency and click on the generate folder. As you can see, the download is completed. So click on this open file folder here and extract this file. Now let's copy that folder and create a new folder called as flight booking system in your any of the drive, and inside that folder just copy this folder. Once this is done, we will use the Visual Studio Code to develop our Spring Boot application. So this is the Visual Studio Code icon. Click on this one. And here you can see open folder option. Choose this option and from here select the flight booking system. And once you choose this option, here you can see the flight service has came. And inside this flight service, the default source folder has been created with main, Java and the flight service application. Along with that, there is one test file also created, flight service application test. And inside the resources, we have the application.property file which is blank. Now let's run this application. Here you can see the message Tomcat started on port 8080. As we have seen, once we were copying the dependency for web folder, the default embedded server is Tomcat, so we can verify from here that it has started Tomcat server and the default port number is 8080. And we can see the message also started flight service application. As for flight service, we want to use MySQL, so let's add some dependencies. So first we will add the dependency for data JPA. Just click on this one and go to the explore option. From here you can copy this dependency. So in the flight service application, go to the pom.xml file and copy here this dependency and click on save. And click here yes to make sure that this will synchronize the Java class path and configuration. Once you save this thing, just stop this server and restart the application again. Now you can see that it is failing to determine a suitable driver class, and it is also giving you some exception related to data source configuration. as we can also see that it is trying to find out some embedded database. Either it could be H2 SQL, or we want to use MySQL or MongoDB. Accordingly, we have to add the library for that one. So again, go to the Spring Initializer and add here dependency for MySQL driver. Explore this option, and from here copy the dependency MySQL and paste in the pom.xml file. And click on save. Say yes. Now let's try to run this application again and see if the error still exists or we have to add still the configurations. So yes, still the error exists and it says fail to configure a data source URL. So now let's try to add some configurations in the application.properties. So in the application.properties, copy this properties. Spring.datasource.url, it specifies the JDBC URL for connecting to the database. Here our MySQL database name is FlightDB and it is running on localhost at port 3306. Along with that, we have given additional parameter like JDBC:MySQL. Spring data source.username. It specifies the username to be used for authenticating with the database. In my case, I have set this value to root. The next one is password, which is also used for authenticating the database. In my case, it is password123$. The next one is Spring Data Source Driver class name. This is very important and it specifies the fully qualified name of JDBC driver to be used for connecting to the database. Spring JPA Hibernate DDL Auto. It specifies how Hibernate should handle the database schema during the application startup. In my case, I have set this to the update, which means Hibernate will attempt to update the database schema based on the entity mappings and perform necessary changes without dropping the existing tables. Spring JPA shows SQL. It specifies whether Hibernate should output the generated SQL statement to the console. In my case, I have set this value to true, so Hibernate will log the SQL statements for debugging and analysis purposes. Now let's rerun this application again. If you scroll this up, at the top you can see some exceptions. It is not able to find this database FlightDB. So let's create this FlightDB database first in the MySQL schema. This is the MySQL workbench, and here if you can see we do not have any schema which is named as FlightDB. So now from here let's go and create a schema called as FlightDB and click on apply and finish. Now you can see here the FlightDB has been created without any tables. Now let's try to run our application again. Now you can see the flight service is up and running. So I hope now you remember the steps. The first step was we have to add the two dependency here. The first dependency is the Spring Boot starter data JPA and the connector. In our case we are using MySQL, so we have used MySQL dependency. Along with that we have to add the configuration in application.properties as we have seen here. Our basic setup is ready. Now let's create the entire application inside our flight service. Stop this service and let's create some packages. So inside this flight service module, let's create another package called as controller. This controller acts as a controller layer. Then we can define few more packages here called as service. Now for persistent layer we can define few more packages like repository and entity. This entity is used to persist the data in database. The next one we will define here is the model class. This model class will have the request and response objects. Inside this controller, let's define one class called as flightcontroller.java. First we will use the REST controller, and then another one we will be providing the request mapping. So this is the entry point for our flight controller with the mapping as /v1/api/flights. And as you can see, these annotations are coming from Spring Framework web.bind.annotation. Create flight API. For creation of this flight, we will use a post mapping, and we will use flight request as a request body and flight response as a response body. So let's create this. Throughout our course of microservices, we will follow the similar pattern like what we are using in the flight. For example, the flight request, flight and flight response. For creating a MVC architecture pattern to separate the concern and facilitates a clear separation of responsibilities within our application. So for example, here the flight request, it encapsulates the input data provided by user or client, and we will pass this request to the controller. And then the flight class represents the flight related data which we will be passing to the persistent layer or any other data source for persistence. And the flight response class represents the response or the result of flight related operation or request. Inside this model package, let's define the flight request. Instead of defining this as a class, we will use here record. Record is a new feature introduced in Java, which is a concise way to declare a class whose primary purpose is to store data and provide access to that data through automatically generated methods like constructor, equals, hashcode, and strings are automatically generated methods. Let's try to add some fields in this parameter. By default, all the fields provided here are private and final. We will create some basic fields like what is the flight number, what is the origin, what is the destination, departure date along with the arrival date, and total seats available for a flight, and out of the total seats how many seats have been consumed. So we will track this in the available seats, and what is the amount for that field. Let's define a class called flightresponse.java. And we are not using this class for record. I can explain you later why we are not using this class for record. And here we can add the same parameters what we have defined in the flight request along with one additional parameter called as flight ID. This flight ID we will be defining in the flight class. Now let's generate getter and setter for this class using the data annotation, and we will define a no argument constructor, and we will define all argument constructor and a builder pattern to build this class. As you can see, all these annotations are coming from the Lombok. As we have already seen that this library is used to reduce the boilerplate code. So now you can see with this 4 annotation how quickly we have defined this class. We don't have to use any getter and setter, no need to define any argument for any of the constructor, or we can also use the default constructor. Let's go to the flight controller class and import these classes. And also add a return statement. For time being, I am just adding a null statement, and then we can add the required code for this functionality. In the services folder, let's create the interface flight service. And define one method here as we are defining in the flight controller. Then we can define one more class, flight service IMPL. And this is a class which will implement this interface. And from here, click this option to add the unimplemented method. This create flight method will consume the flight request and it will generate a flight entity, and this flight entity we will persist in our database. So let's create that entity flight. This flight will have the same parameter as we have seen in the flight response. We will also use flight as a class, not as a record. I will explain very soon this why we are using class for flight and flight response and record as a flight request object. So let's annotate this with entity annotation to persist this value. And you can notice here this entity is coming from the Jakarta. So from Spring 3.0 onwards, all the persistence API has been moved to the Jakarta package and it is not used from the Spring annotation classes. So by default it will store in DB the flight as a table of name. If you want to change the name, we can define the annotation called table and with the name attribute as flights. So it will store now the table name with flight details. For the flight ID, let's create an annotation ID to make this as a primary key for our database table. The generated value annotation is used to specify the strategy for generating the value for primary key. And we will use this strategy as identity, which means the primary key values are automatically generated by MySQL database and it is unique value when a new row is inserted. We'll add some more attributes like data to generate the getter and setter, and you can see now the yellow indicator has been gone. We can also define no arg constructor and all argument constructor. Along with that, we can define this for the builder pattern. We need to persist this entity, so for that we will create a repository here called as flight repository. And this will be an interface. Let's extend this with the JPA repository. As you can see here, the JPA repository is expecting some parameterized type. So let's add two parameters here. The first is the entity name, that is the flight, and second one is the primary key of this entity. So if we go here, we can see the long parameter. Let's copy this one and let's paste here. Still it is complaining. As you can see, it is expecting the wrapper type. We cannot add the primitive type, so let's keep this as a wrapper type and import this class. So we can see now all the errors are gone and we do not have to annotate this flight repository with repository annotation, because from Spring 3.0 onward the repository annotation is not mandatory. Let's quickly change this long parameter from primitive type in our flight response and the flight model. We have flight and flight repository in place. Let's move to this flight service.impl class. Here we will develop the business logic. So now let's remove this code, and here we will create the flight entity. And this flight entity we will create by consuming the flight request. So say flight.builder.build, and here we can define some additional parameters. With this builder method, now we have defined some of the attributes what we have defined for flight entity, like flight number, origin, destination, etc. And you can notice one thing here, this flight request is not a class, it is a record, right? So with record we can directly achieve the name using the field of the name. For example, the flight number, here we cannot use the get flight number. So if you see here, there is no get method available here, and there is no set method available in the record. We can directly achieve using the name. We can persist this flight now inside the flight repository. So let's define the flight repository, import this class, and annotate this using the AutoWire. We have two options, either we can use the AutoWire to invoke the flight repository, or we can go with the require arc constructor. So during the construction of this flight service IMPL object, the flight repository will be invoked and it will be initialized. Ideally, the requirement argument constructor is a better approach, because sometimes there may be chances that this repository can be modified accidentally. So we can go with the require arc constructor. And for defining this requirement argument constructor, to make sure it should not be modified, we have to add the attribute final and click on flight repository.save. At last we will return the flight response object. So we will use this flight object and we will compose the flight response object using bnewton.copy properties. And this is designed to copy property values from one object to another object using reflection. As we know that the record classes will use the parameterized constructor while defining the field, so we cannot create a default constructor for flight request. So during the initialization itself we have to provide this parameter. So that is one of the reason we cannot use this record classes with bnewton.copy properties, and I have suggested to use only the flight request model as a record, and other entities like flight and flight response to be considered as classes. Let's remove this one and we will have a return statement. Along with that, we can trace the log. So Lombok will provide two utilities. The first one is the SL4J and the second one is log4j. You can use any of these things. We are going with the SL4J utility. We have this log info flight created, and here we can use the open and close parenthesis to get the dynamic value. So here the flight ID can be generated dynamically. We also need to add the service annotation to this class. Let's move on to the flight controller, and here in the flight controller we will invoke the flight service. Here also we will use require arc constructor. In this line, a local variable named flight is declared using the var keyword. The where keyword in Java is a type reference feature introduced in Java 10. It allows you to declare local variables with the implicit type interference, reducing the verbosity of code and making it more concise. So when we use the variable called where, the type of variable is interfered by the Java compiler based on the initializer expression on the right hand side of the argument. In this line, a response entity object is created using its constructor. The constructor uses two arguments. The first argument is the flight, which is the response body, and the second argument is the http status.created, which is the status code to be sent in the response. Now we have implemented the code for flight service. Let's run this application again and see everything is working fine. And yes, everything is working fine. It is running successfully on port number 8080. We will use Postman to test our API. So first let's create one collection. Click here and click on new collection and give the name as flight booking system. And here we can create a request. So our request is a post request. So let's create a post request and it should be http localhost 8080. Our port is 8080 and we can add here the API details. We can cross verify these details from here. In the flight controller we have defined this API /v1 API /flights. Now here go to the body section and here we can define the data type as raw and the text as JSON. We will compose the JSON request here with opening and closing bracket. And here we can add all the flight request objects. So let's go here and open your flight request class and just copy all this parameter. So we have added the remaining details here with origin as Dubai, destination as Switzerland, departure as 28 June 2023, arrival date with 30 June 2023, total seats 250 and the available seats also as 250 with amount as 1000 AED. Now once our request is ready, let's try to send this request. And we can see the status message as 201 created. Now let's go to the Preet and here we can see our flight response with the flight ID 1, flight number and the remaining details. This new request we can save it. Okay, so let's try to save this request with the name flight service create flight. So in future it is easy to refer this request again. We can verify this entry in MySQL database also. Let's first refresh this DB and here we can launch this notepad and here we can type this command select star from flightdb.flights and we can execute this command using this yellow arrow and we can see here one entry has been created successfully. We have now seen the entire flow for creating the flight from the Postman as well as from the MySQL workbench. Now let's create one more API in our flight service to get all the flight details. We can use the get mapping to get all the flights and the response type should be list of flight response and the status code should be http status.ok. So now let's define this thing in the flight service. So inside the flight service we have defined this method called as get all flights and we will provide the implementation in flight service IMPL class. So inside this flight service IMPL class first we will use the flight repository to find all the flights and it will return the list of flights
and from this flights we will get the flight response. As this is a list, we can use the stream utility from Java 8, and then we will map this one to the flight response object. So for this I have created a private method. This private method will take the flight as an input parameter, and it will use beanutil.copy properties to copy the flight into the flight response object. So this thing will happen for all the list of flights, and then we will collect this into the collector.toList utility. So this is how we will get the flight response list. This is too easy, right? Our API is ready. Let's verify this API. So first we will start our application again. It is started successfully. Now go to the Postman API and here type the GET request, and we will provide this parameter http localhost 8080 with v1/api/flights. Now click on the send button, and here we have only one object, so we can see we have received only one list. Now let's see how we can add some specific fields which are not available in the repository. So for that we have to write some additional methods in the repository. So we will try to check for get flight by number. So here for this thing we have defined a gate mapping, and here we have defined the path variable as id, and you can notice here that we are using the flight number, and we can define any of the mapping here. But if we want to use this id, we have to make sure that this can be used inside the path variable with codes. So here whatever name you can define, it is completely fine, but it should have mapping for this id from the get mapping. Okay, and then in the flight service we can define this method. So go to the flight service, and here we can define this flight response get flight by number with this string which is taking the flight number as an input, and then we will provide the implementation for this class. So inside this flight service IMPL class we have defined this method. So first we will log the message, and then we will use the flight repository called find by flight number. So inside the flight repository method we have defined this method using the optional interface, and this will be the optional for the flight and find by flight number. So if you see here inside this flight method we have this flight number, so we have to make sure that the same name has been used here in flight repository with the first letter capital. So find by flight number.
We will now understand what is global exceptional handling and what is its importance, and then we will try to implement this in our application. Global exception handling refers to the practice of handling exceptions that occurs across multiple components of an application. Instead of handling exceptions separately in each individual component, global exception handling allows you to define a common mechanism to handle exception consistently throughout the application. For this, we can use annotation to define a central exception handler that will be invoked whenever an exception occurs within the application. We will also use controller advice to define global exception handlings for our controllers in Spring MVC applications. Global exceptional handling offers several benefits like consistent error responses. By centralizing exceptional handling, you can ensure that error responses provided to client are consistent and they followed a predefined format. This helps maintain a uniform user experience and make it easier to handle and process errors on the client side. The next one is code decoupling. Global exceptional handling helps decouple the exceptional handling logic from individual components of the application. The next one is centralized logging and error monitoring. With global exceptional handling, you can easily log exception and capture error information in a centralized manner. Exception translation. Global exceptional handling allows you to translate or map different types of exception to a common set of error codes or error messages. This abstraction helps to hide the implementation details and provide a consistent view of errors to the client. Custom exceptional handling, on the other hand, involve handling exception at the specific point within the code where they are likely to occur. So developers explicitly define the try-catch blocks around the portion of code that are prone to raising the exceptions. This approach allows for more fine-grained control over exception handling, enable different action to be taken based on the specific exception type or context. By using custom exception handling, developers can handle exception in a manner appropriate for the situation. They can provide specific error messages, perform specific error recovery action, or propagate the exception to the higher level of the application for further processing. Custom exception handling is often used when different exceptions need to be handled differently or when a specific exception handling logic is required.
So let's define one class in exception package called as flight controller exception handler class.
This class is annotated with controller advice indicating that it handles exception across multiple controllers. It extends response entity exception handler, which is a convenient base class provided by Spring that already provides some default exception handling behavior. The exceptional handle annotation is used to specify that handle flight service exception method handle exception of type flight service custom exception. Let's try to understand the use case for flight service custom exception in our application. We will see this usage in the API get by flight number.
It may happen that the flight number what we are requesting is not available in the database. So it's advisable to throw some exception. So in such scenario we can define our own customized exception. So I have defined one exception called as flight service custom exception, which will take two parameters. The first parameter is the message where we can define the custom message and the error code. So let's see this class. So for this thing I have created one separate package called as exception inside this flight service, and here we have defined this class. So this class will take two parameters. The first parameter is the message and second one is error code. And also you have noticed that this class is extending the runtime exception.
We understood the importance of flight service custom exception usage. Let's go back to the flight controller exception handler class to understand handle flight service exception method. The method receives the thrown exception as a parameter name exception, allowing you to access the detail of exception. Inside the method, a new response entity object is created using its constructor. It takes two arguments. The first argument is an error response object constructed using the error response.builder method. The builder method is used to start building the error response object, and the error code and error message field for the error response objects are set using the values obtained from flight service custom exception object. The build method is called to create the final error response object. The second argument is http status.notfound, which represents the http status code to be sent to the response. In this case, it is set as 404 not found. Finally, the constructed response or entity object is returned, which encapsulates the error response object and the HTTP status code. And this response will send back to the client as a result of handling the flight service custom exception. By customizing the error response and HTTP status code based on the exception details, you can provide meaningful error response to the client. conveying information about the encountered exception in a standardized way.
Our API now get by flight number is ready, as we have already defined a global exceptional handler called flight controller exception handler, and also we have defined the custom exception called as flight service custom exception. And as well we have seen this implementation in the flight service IMPL class. So here we are invoking this method. So now let's try to verify our controller for this API. So we will start our services and we can verify. Now let's run our application again. And in the Postman we can verify this API. So let's define this endpoint and click on send option, and we can see we are able to see the response. Now let's verify by providing some wrong input, let's say 404, and send this exception. So here we can see the error message with the information what we have provided, flight with given number not found, and with the error code flight not found. So now you can see how simpler it is, easy to see this error message and error code irrespective of getting such a big exception, isn't it? So the customized exceptions are really very useful to show the error messages in a standard way.
For time being, that's all for the flight service module. Now we will see the next module as flight search service.